Okay, this is going to be part 2 of our notes on 8.0. In this video, we're going to be looking at simplifying radical expressions. So to start, we want to go over some vocabulary here. When we're looking at a square root here in pink, the formal name for this is called a radical. And the number underneath there in green, we call that the radicand. This is the number under the radical sign. Now, as we go out through the video, you're more than likely going to just hear me refer to that as the number under the square root. Okay. To start off, though, we do want to talk about, what does it mean for a square root to be simplified? So if square root is in simplest form when these three things are true. When the radicand contains no perfect squares, remember that's just the number under the square root. When the number under the square root contains no perfect squares. When the number under the square root is not a fraction. And when there are no radicals in the denominator, right? So these three things have to be true for a radical to be in simplest form. So let's go ahead and look down below here where we can see some steps on how it is that we're going to simplify these radicals. So step number 1 here is going to consist of us creating a factor tree of the radicand until you end with prime numbers. So a factor tree is just going to be consisting of us splitting up that number under the square root into two numbers that multiply to give us 3. Or in this case, the example we have here is 60. Now you're going to keep splitting this up until you end with prime numbers. And what is a prime number? Remember that a prime number is a number that can only be divided by 1 and itself. So some examples of prime numbers are 2 is a prime number, 3 is prime, 5 is prime, 7, 11. These are prime numbers. So when you're creating your factor tree, you keep going until you end up with prime numbers. Step number 2 is you're going to replace the radicand with all the numbers at the end of your factor tree. So let's go through this step-by-step process with the 60 that we have here. So this would be the process for us simplifying the square root of 60. Step number 1 would consist of us making this factor tree. And what I like to do is I like to circle the numbers at the end of my branches, my prime numbers. Now, step number 2 is telling you to replace that square root of 60 with the numbers that you have at the end of your branches. We have 2 times 3 times 5 times 2. So if we were to write that down, that would be step number 2. Now, step number 3 is telling you to simplify. For every pair of the same number, you're going to pull 1 out of the radical. So here what we see is that we have a pair of 2's. Now, these 2's aren't right next to each other, but that's okay. I have a pair of 2's nonetheless. Now, for every pair of the same number, they cancel out and one of those comes out. So only 1 2 comes out. Now, the reason for this is because what I just circled was under the square root, I just circled 2 times 2, which that gives us 4. So the square root of 4 is 2. That is the reason, the math behind us just pulling out 1 2. Now, what we do next then is we just check to see what do I have underneath the square root. 3 times 5, which that gives us, if we were to simplify that there, 15. So 2 square root of 15 would be the simplified form for the square root of 60 here, right? So that's walking through that process step by step. Now let's look at the examples here down below. If we look at the square root of 54, well, we just need to go ahead and find two numbers to create our factor tree. Create two numbers that multiply to give us 54. Well, if you're not sure what to start with, if this number is even, well, you can always start by using 2. I know 2 times 27 would give us 54, and 2 is prime, so I'm going to circle it. 27 can be broken down into 3 times 9. 3 is prime. And 9 can be broken down into 3 times 3. And we have finished our factor tree. We ended up with prime numbers all the way at the end. So what ends up happening here now is that this square root of 54 is going to be replaced with the prime numbers that we ended with. So we have 2 times 3 times 3 times 3. And we're looking for a pair of the same numbers here. Well, I see a pair of 3's here. Now for this pair of 3's, that's 3 times 3, which is 9. So we're really looking at square root of 9 here. That means that we're just going to take one of those 3's out. And then what we're left with here is, well, the numbers under the square root are 2 times 3. So 3 outside of the square root times underneath the radical there we have 6. 2 times 3 gives you 6. So our answer here in simplest form is 3 square root of 6 when simplifying root 54. All right, let's try another one here. Now on number 2, what you'll notice is there's already a number outside of the square root, right? We have 2 times square root of 50, right? So if we're going to go through that process, well, let's go ahead and break down 50. I know 5 times 10 gives us 50, and 5 is prime. If I go to break down the 10, we have 5 times 2, and these are also prime. So what we're going to do now is we're going to rewrite that radical that was provided to us. We're going to write 2 square root of 50. You don't want to forget that there was already a 2 out in front, right? So let's not forget that. But instead of writing that 50, what you're going to write is the numbers at the end of your branches. We have 5 times 5 times 2. And we see here quickly that we have a pair of 5s. That means 1 5 is going to come out. And we had that original 2 that was already on the outside. And underneath the square root, all we have left remaining is a 2. So what you might be wondering right now is, well, what happens if I have more than 2 numbers that end up outside the square root? Well, you multiply them together. So this ends up being 5 times 2, which is 10. And then we have square root of 2. So there's our answer simplified. Right, we'll go ahead and practice with one more here. We have 4 times square root of 108. So a slightly bigger number here. Let's go ahead and break down the 108. So again, if you're not sure, we can work with the fact that this is an even number. So this would be 2 times 54 is how I can begin to break this down. I know 2 is prime. 54, well, hey, we actually did that earlier over here, so we can go ahead and just continue the same process. 2 and 27. The 27 gets broken down into 3 times 9, and the 9 gets broken down into 3 and 3. So what we do now is, again, we replace that number under the square root, that 108. So we still have that 4 on the outside, but now underneath the 108 instead is going to become 2 times 2 times 3 times 3 times 3. So we have 2 times 2 times 3 times 3 times 3. And we're looking for a pair of the same numbers here. Well, we have a pair of 2s. So that means 1 2 is going to come out. We also see here that we have a pair of 3s. So that means a 3 is going to come out. And then we also had that original 4 that was on the outside, right? And remember we said that multiple items outside of the square root get multiplied. And then now we just check, what do I have left remaining under the square root? Well, these canceled. All I have left is a 3. So all that's left for us to do is to multiply. 2 times 3 is 6, and 6 times 4 is 24. So this becomes 24 square root of 3. All right, so there is our process on simplifying radical expressions, right? So this is known as prime factorization. What we're going to look at here next on the notes is, well, how do I do this another way? So we can also simplify radical expressions by using perfect squares. Now, this process is going to require 2 things. It's going to require you to have your perfect squares memorized, which we have a list of them right here. And it's also going to require you to really be good at your multiplication facts. So the steps on how we can simplify things like this a little bit quicker is by looking at step 1. Find the largest perfect square factor. So I'm looking at the square root of 72. I want to see, how can I break this up where one of the numbers is a perfect square, and I want it to be the biggest perfect square. Well, what I'm thinking here is I can break up the 72 into the square root of 36 times the square root of 2. And I already know the square root of 36. Square root of 36 is just going to be 6. So this becomes 6 root 2. Right? So this process, we're already done. Right? This process is a lot faster, but again, you have to know your perfect squares and you have to know your multiplication facts. Right? We can see this in practice again with number 5. We have square root of 300. Well, I know I can break this up into 2 numbers that multiply to give me 300, and I want to do this strategically. The 2 numbers that I pick, I need one of them to be a perfect square, right? Specifically, the largest perfect square. So in this case, we can say, hey, 100 times 3 gives me 300, and breaking it up this way gives us a square root of 100, which is 10, and then we just have square root of 3. Right? So this is a more efficient way of doing it, but again, need to know your multiplication facts, need to know your perfect squares. Now, for the rest of the examples that we have in the notes for this video, you're going to see me simplify the radicals like this. So let's go ahead and look to see what we have up next. Up next, we're looking at how do we add and subtract radicals. So when adding and subtracting radicals, we need to understand that the radicand, remember this is the number under the square root. So if you're going to add or subtract radicals, the number under the square root must be the same, right? And we have to simplify radicals if necessary before actually checking, right? But what you end up doing if the radicals are the same is you add or subtract the numbers in front, but you leave the radicals the same. So an example that we have listed down here is we have 3 square root of 5 plus 4 square root of 5. Now we can add these up because the number under the square root is the same. Okay, you can think of these kind of like terms, right? So 3 square root of 5 plus 4 square root of 5. How do we add that? You simply just add the numbers in front. 3 plus 4 give you 7. So your answer is 7 square root of 5. The square root you leave alone. You just add the numbers in front or subtract. Right? An example of what we cannot do is if we have 3 square root of 5 plus 4 square root of 2, what you'll notice here is that the numbers under the square root are not the same. I cannot combine them. So that would simply just stay the same. That could not be simplified. You would just leave it as 3 square root of 5 plus 4 square root of 2. Looks a little weird, but there's not much more we can do beyond that. So let's just look at 2 examples here really quickly. It says, what is 6 times the square root of 2 plus 4 square root of 2? Well, we're seeing here the numbers under the square roots match. So you just add the numbers in front. This means we have 10 square root of 2. And there we have it. Now, if we look at this example here, we have what is 5 root 3 minus root 27? Well, right now I'm seeing here that the numbers under the square root do not match. They're not the same. But what I am realizing here is that this square root of 27 can actually be simplified. Now, if I'm going to simplify this, I'm going to do it the second method that I just showed you. I know 2 numbers that multiply to give me 27. I know 9 times 3 gives me 27. And I know the square root of 9 here is, well, that's 3. So this becomes 3 root 3. So if I were to rewrite this question, what you have is 5 square root of 3 minus 3 root 3. And now what do you know? Those numbers under the square root match. So yes, you can actually subtract these. If we're going to subtract, just look at the numbers in front. 5 minus 3, that's 2. And the square root stays the same, so 2 root 3. So that's how you add or subtract radicals. Now let's go ahead and take a look at how do we multiply and divide radicals. When it comes to multiplying radicals, we're going to look at this process right here. You're going to multiply the numbers in front together, and then you're going to multiply the radicals together. Simplify once you're done if necessary. Right? Dividing radicals works very similarly. You're going to divide the numbers in front together and divide the radicals together. Simplify when you're done if you have to. So let's look at what this looks like. So when it comes to multiplication, it's not a requirement for these to be the same. But if we're going to multiply, you just multiply the numbers out in front together. 4 times 2 is 8. And let me write that a little neater there. And then you multiply the numbers under the square roots together. 3 times 15, well, that is square root of 45. Right? And the expectation in this class now is if you have a square root for an answer, you want to make sure that it is fully simplified. I'm telling you right now that the square root of 45 is not fully simplified. So if we're going to simplify that, I can break up the 45 into, well, 9 times 5 gives me 45. And I'm doing this strategically because I know the square root of 9 is just 3. So this becomes 8 times 3 times the square root of 5, which is 8 times 3 gives you 24. So 24 square root of 5. Now, if you're not super comfortable simplifying this way, breaking it up, this part right here, breaking it up into 2 numbers where one's the perfect square. If you're not comfortable with this method, you don't have to do it. You can do your factor tree, right? You can do your 45 like we did earlier and still get the same answer, right? It boils down to what you're comfortable with and what you're able to do. So let's look at the second example we have here. We have 8 square root of 60 divided by 2 square root of 10. So like we said earlier, what we're basically doing is we're just working with the numbers in front, 8 divided by 2, and then you're working with the numbers under the square root. So if we're going to work with the numbers in yellow, they're out in front. 8 divided by 2 is 4. And then square root of 60 divided by square root of 10, well, you're just going to divide 60 by 10. 60 divided by 10 is 6. So this becomes 4 square root of 6. So that's how you divide radicals, right? And we'll finish up this video with probably the most important part for this chapter, which is going to be a process known as rationalizing the denominator. So at the beginning of this video, we talked about what it meant for a square root to be in simplest form. So we're just going to kind of reiterate that here. For square roots to be simplified, there can be no radicals in the denominator, right? So for example, these little problems that we have down here at the bottom, I have a square root or radical in the denominator, which is the bottom part of the fraction. That means it's not fully simplified, right? We need to fix that. So to fix this problem, what you're going to do is you're going to multiply the top and the bottom by the square root that's in the denominator, and then we're going to simplify. So if we're going to take a look at that, you have 10 over the square root of 2. So let's just write that underneath here. Now, what we're being told here is if we want to fix this problem, you have to multiply the top and the bottom by that radical that's in your denominator, in this case, radical 2 or square root of 2. So to fix this problem, we're going to multiply the top and bottom by square root of 2. Now, if we do this, when we're multiplying fractions, remember you multiply straight across the top. So 10 times square root of 2, well, that gives us 10 square root 2. On the bottom, square root of 2 times square root of 2, we learned earlier how we multiply radicals, which means you multiply the numbers out in front and you multiply the numbers under the radical together. So square root of 2 times square root of 2 is square root of 4. And what we end up seeing here is we can simplify that. The top stays the same right now, 10 square root of 2 over, but now on the bottom you have the square root of 4, which we understand that the square root of 4 is just 2, right? And then the last thing you want to check for here is once you've cleared and gotten rid of that square root in the denominator by doing this, check to see, can this fraction be simplified? Now I see that this fraction can be simplified because I can divide 10 by 2. 10 divided by 2 is going to give you 5. So this fully simplifies down to 5 square root of 2. So our answer here is 5 root 2, right? And that's the process that we call rationalizing the denominator, right? So let's practice with another one here. Here we have 7 over the square root of 3. So 7 over square root of 3. Now again, we end up with a square root or radical in the denominator, right? To fix that, multiply the top and bottom by that same amount, which in this case is square root of 3. Now if you multiply straight across, you get 7 square root of 3 on the top. On the bottom, square root of 3 times square root of 3 is square root of 9, right? If we keep going here, you have 7 square root of 3 over, well, the square root of 9 is just 3. What I would do now is I would check, can I divide 7 by 3? In this case, you can't. So we would just leave our answer like this. So our answer here is just going to be 7 square root of 3 over 3, right? Looks a little bit weird, right? But that's just going to be how some of our answers end up sometimes when dealing with radicals.